Rational exponents. Today we're going to simplify expressions with rational exponents. First, what is a rational exponent? A rational exponent is an exponent that is a fraction. The numerator is the power and the denominator is the root. So if you have a to the power of m over n, the m is your exponent or your power, and that can go on the inside or on the outside, and then the n, the denominator, is the index or is the root. So if I had 5 to the 2/3 power, that's the same as power over root, that's going to give me 5 is my radicand, 3 is my root, and 2 is my power. Now the 2 can be on the inside, or you can move the 2 to the outside. It really doesn't matter. And we'll go through a few problems. Here we have negative 32 to the power of 3/5. So we're going to change that to negative 32 inside the house to the 5th power cubed. Now, negative 32 cubed is a really big number, so I don't want the cubed inside. Instead, I put the cubed on the outside, and I say, what is the 5th root of negative 32? Well, the 5th root of negative 32 is a negative 2, and we're still raised to the 3rd power, which gives us an answer of negative 8. Next, I have 8 as the index, 13 to the power of 4. What that's going to look like is 13. Remember, it's going to be the power over the root. So 4 over 8. That can be reduced to 13 1/2. And that's what they want. Now, I do want you to notice that a power of 1/2 is the same thing as saying the square root of 13. These are the same things. Next, they give me 36 over 49 to the power of 3/2. I'm going to split this up. The 3/2 is outside the parentheses, meaning it's talking to the top and it's talking to the bottom. So 36 to the power of 3/2 and 49 to the power of 3/2. That gives us the square root of 36 cubed over the square root of 49 cubed. Gives me 6 cubed over 7 cubed, which gives me a final answer of 216 over 343. Now, a little review of our basic math skills. When we're multiplying like bases, what do we do with those exponents? We add them. That's going to give us 5 to the power of 5. For those of you that don't remember these general math rules, make sure you review General Math Review number 6, Exponential Operations. That reviews all of the multiplying, dividing, like bases, as well as some other things. Anyway, 5 cubed gives us... So when dealing with fractional exponents, we follow the same rules. I have like bases of 36. The exponents are 3/8 and 1/8. If I'm multiplying like bases, I'm going to add those exponents. So that gives me 36 to the power of 3/8 plus 1/8. When adding fractions, remember to add straight across and keep your denominator the same. And don't forget to reduce at the end. 36 to the 1/2 is the same as square root of 36, which gives us an answer of 6. Now remember, when adding fractions, we have to have common denominators. So here I have 2 to the power of 1/3 times 2 to the power of 3/5. I have like bases, that's great, but I need to add 1/3 plus 3/5. In order to do that, I need common denominators. What I'm going to do is I'm going to multiply the left-hand side, the bottom, by 5, and then multiply the right-hand side, the bottom, by 3. What that's going to do is give us a common denominator of 15. Now, whatever I do to the bottom, I have to do to the top. That means I have to multiply the top by 5 there. 1 times 5 is 5. Plus, I have to multiply this by 3. 3 times 3 is 9. That gives me 5 plus 9 is 14/15. So my answer here will be 2 to the power of 14/15, and we can leave it as is. Next, I have the square root of 7 times the cubed root of 7. Well, I can't multiply these because they have different radicals. So what I'm going to do is I'm going to change them into rational exponents. 7 to the power of 1/2 times 7 to the power of 1/3. Now I know I have a common base of 7, and I can add these fractions. I need common denominators. I'm going to multiply the 3 times the 2. Whatever I do to the bottom, I do to the top. I'm going to multiply the other 3 times a 2. Whatever I do to the bottom, I do to the top. That's going to give me a common denominator of 6. And on top, that gives me 3 plus 2 gives me 5 over 6. My final answer will be 7 to the power of 5/6. Now, we just said when multiplying common bases, 5 and 25 are not common bases. There's actually two ways to do this problem. The first way is to change them into radicals. It gives me the cubed root of 5 times the cubed root of 25. When we multiply that, they're both cubed roots, which is fine. So 5 times 25 gives me the cubed root of 125. You should know that the cubed root of 125 is simply 5. That is one way of doing it. The other way of doing it is with the fractional exponents. 25 is the same thing as saying 5 squared. So 25 to the power of 1/3 is the same thing as saying 5 squared with the power of 1/3, or saying 5 to the power of 2/3. So what I'm saying here is that 25 to the power of 1/3 is the same as 5 to the power of 2/3, because 5 squared is 25, and then we still have the 1/3. So the other option for multiplying these out will be 5 to the power of 1/3 times 5 to the power of 2/3. When I add 1/3 and 2/3, I get 3/3, which reduces to 5 to the power of 1. You don't need to write an exponent of 1. If there's no exponent, we already know it's a 1. Dividing bases. Whenever I divide like bases, we simply subtract the exponents. So the quick simple way is saying 5 cubed divided by 5 squared would be 3 minus 2 is equal to 1. So that gives me 5 to the power of 1, or simply 5. Now, why does this work? We know that 5 cubed over 5 squared looks like this. Then I can cancel out like terms, leaving me with the final answer of 5. This is why subtraction works. I expect you to be able to subtract these. So for the first one here, we have 5 to the power of 9/4 divided by 5 to the power of 1/4. We simply take 9 over 4 and subtract it from 1 over 4. 9 minus 1 gives us the 8/4, which reduces to 2. The answer to this will be 5 squared, which is equal to 25. Again, we have 16 to the 3/4 over 16 to the 5/4. We have 3 over 4 minus 5 over 4. And what that equals is 3 take away 5 is a negative 2 over 4, or a negative 1/2. Well, how come it's negative? Look at it this way. The top disappeared completely, and the bottom is what was left over with the 1/2. That gives you 1 over 16 to the power of 1/2. Don't get hung up on the negative sign yet. Look at it this way. If you don't want to write it with the 3/4 in the front, we could have written it backwards, understanding that this is the top and that is the bottom. Either way, that gives us 1 over the square root of 16, which is simply 1/4. Now, what happens if you have different denominators? Then you need to change them. So I have 3/5 minus 3/10. I need to multiply the left-hand side by 2. Whatever I do to the bottom, I do to the top. That gives me a common denominator of 10, and 6 minus 3 gives me 3/10. I'm left with x to the power of 3/10. For this one, I'm going to change it to fractional exponents. It gives me x to the power of 3 over 2 divided by x to the power of 2 over 3. Make sure you notice which one goes where. That gives me 3/2 was the top minus the 2/3, which is the bottom. I need common denominators. I'm going to multiply the left by 3 and the right by 2, which gives me a common denominator of 6. And 9 minus 4 is equal to 5 over 6. Notice the top was bigger, so that means that the bottom was going to cancel out completely, giving me a final answer of x to the power of 5 over 6. Next, if I raise an exponent by an exponent, you simply multiply the exponents. We have 5 to the power of 2 raised to the power of 3. The long complicated way would be I have 5 squared 3 times, which means I have 25 3 times, which would give me an answer of Now, the best way of doing it is simply to say 2 times 3 is equal to 6. So 5 to the power of 6 is equal to. Now, how does that look in fractional exponents? If I have 6 to the power of 1/2 raised to the power of 6, all you're doing is multiplying the 1/2 and the 6. 1/2 times 6 is simply 3. So I have 6 to the power of 3, which multiplies to 216. The next one, there's a lot of things here. The first thing I'm going to do is I'm going to convert or change this into fractional exponents. That gives me. Now, if you notice inside, I have like bases. Well, if I'm multiplying like bases, I can simply add the exponents. What is that going to look like? If I have x to the power of 1 times x to the power of 1/2, I need common denominators. Well, this is a 1 over 1. In order to add, I need to make common denominators. In order to make common denominators, I'm going to multiply the 1 by 2 on top and bottom, plus the 1/2 that's already there. That's going to give me 2 plus 1 over common denominator of 2, or simply 3/2. Now I'm going to rewrite my problem one more time. Now I can simply distribute 2/3 into all of the pieces. And that's going to give me -8 to the power of 2/3. X is going to multiply 2/3 times 3/2. And that's simply 1. And then y is going to multiply 1/2 times 2/3, which is simply 2/6. 8 to the 2/3 is saying the same as the cubed root of -8 squared, and that gives me -2 squared, which gives me a positive 4. The x comes straight down, and the y to the 2/6 can be reduced. 2/6 reduces to 1/3. Negative exponents. When an exponent is negative, you flip it upside down, or basically you take the reciprocal of whatever that one piece is. So here I have x to the power of -2. Remember, all whole numbers are over an invisible 1. So what happens is I flip that to the bottom. Once I flip it to the bottom, the exponent who was negative is now happy because he's on the bottom where he wanted to be originally. How does this look with fractional exponents? Pretty much the same thing. You just have 32 to the power of -3/5. So what that means is that the 32 doesn't want to be on top because it's a numerator over an invisible 1. It wants to be flipped to the bottom. So you say 1 over 32 to the power of 3/5. And now you treat it like a normal fractional exponent. It gives you 1 over the 5th root of 32 cubed. It gives you 1 over 2 cubed, which is simply 1 over 8. Notice the negative exponent had nothing to do with the sign of your final answer. The negative exponent only tells you to flip the 32 to the bottom. Here's another. Now the properties of power to power are still the same, even with the negatives. So remember, the power on the 16 is an invisible 1, so I'm going to multiply 1 times -3/4. -8 times a -3/4. Well, negative times negative is a positive. That gives me y to a positive 24/4. Now we should reduce that. 24/4 becomes 6. Now the 16 is a negative exponent. So that means the 16 wants to go down to the bottom. But the y, he's a positive exponent, so he's going to stay right where he is. Y to the 6 stays on top because he's happy where he is. But the 16 to the -3/4, he needs to go down to the bottom. That gives you 16 to a positive 3/4. Now we can simplify that 16 to 3/4. And that gives us a final answer of y to the power of 6 over 8. Now here's one combining multiple things we just talked about. The 1/4 talks to both the 3 and the 6 on the top. So that's going to give you x to the power of 3/4 and y to the power of 6 times 1/4 gives me 6/4, which reduces to 3/2. So y to the power of 3/2 on top over. This negative is going to distribute through. Now notice a negative times a negative is a positive for both of these. That gives me x to the power of 7 halves and y to the power of 3 halves. Take a look at the y's, 3 halves and 3 halves. I have the same y on top and bottom. I can simply cancel that. The x's aren't as easy. If I'm dividing like bases, then I'm subtracting the exponents. So that's going to give me 3/4 take away the 7 halves. Unfortunately, they're not like terms, so I need to multiply the bottom. Times 2 times 2. Now I have my common denominator of 4 on the bottom. Gives me 3 take away 14, which is going to equal negative 11/4. Now, the negative is simply telling me that that's the bottom. What does that mean? That means the top canceled out completely, and that's going to give you 1 over. Now, the 1 has to be there in order to make it a fraction. Everything canceled out on top, leaving only the 1 on top. On the bottom, we had x to the power of 11/4. Do not write the negative. The negative simply told us that that was the bottom from subtraction, from subtracting top to bottom. In our last problem here with some negative exponents, again, we're going to distribute through. Remember, there's an invisible 1 on the negative 32, so that gives us negative 32 to the power of 1/5. Notice this negative sign in front of 32 has nothing to do with the exponents. Then I have x to the power of negative 20 times 1/5 is equal to negative 4. So x to the power of negative 4. Now I need to simplify and fix things. The negative 4 on the x means it's going to go down to the bottom. And when I flip it to the bottom, it becomes a positive. Now the negative on 32 has nothing to do with the exponent, so we leave that there. And we have to the power of 1/5. Well, that gives you the 5th root of negative 32, which gives you negative 2 over x to the power of 4.